Hey everyone, Ivan here. Welcome back to our Computer Science Fundamental series. Today, we're exploring how computers connect and communicate through networks and the internet. We've covered how computers represent and process information internally. Now, let's look at how they share that information with each other, creating systems far more powerful than any individual machine. Think about it. A standalone computer is useful, but a connected one is transformative. The ability to instantly share information across the globe has revolutionized nearly every aspect of modern life, from how we work and learn to how we shop and socialize. Let's demystify how this connectivity actually works, from your home Wi-Fi to the global internet infrastructure. At its core, a network is just a group of connected computing devices that can share information. These networks come in different sizes and types. Local area networks, or LANs, connect devices in a limited area like your home, school, or office. Your home Wi-Fi is LAN, connecting your phones, computers, and smart devices. Wide area networks, or WANs, connect devices across larger geographical areas, like a company with multiple offices around the country. The Internet itself is a network of networks, millions of networks connected together through agreed-upon protocols. Networks require physical infrastructure. Routers direct traffic between networks, switches connect devices within a network, and the physical medium, like Ethernet cables or wireless signals, that carries the actual data. But how does information actually move across these networks? That's where protocols comes in. Standardized rules that govern how data is formatted, transmitted, and received. When you send information across a network, it doesn't travel as a single chunk. Instead, it's broken into small packages called packets. Each packet contains a header with source and destination addresses like the to and from on an envelope. Control information about how to handle the packet, the actual data payload, error checking information to verify the data arrives intact. Breaking data into packets allows networks to be efficient and resilient. Different packets from the same message can take different routes to their destination and be reassembled properly when they arrive. The rules governing this process are defined by protocols. The most fundamental is the Internet Protocol Suite, commonly known as TCP/IP, which has 4 layers. The first one is Network Access Layer, handles the physical connection to the network. The second one, Internet Layer, routes packets across networks using IP addresses. The third one is Transport Layer, ensures reliable data transmission using TCP or UDP. And the fourth one is Application Layer, provides specific services like web browsing or email. On top of this foundation, we have specialized protocols for specific services. HTTP, HTTPS for web browsing, MTP for sending email, FTP for file transfer, DNS for translating domain names to IP addresses. These standardized protocols allow different devices and systems to communicate seamlessly regardless of their hardware or software. Every device in a network needs a unique identifier, an IP address. It's like a postal address for digital information, telling the network where to deliver data. Traditional IP version 4 addresses look like 192.168.11, 4 numbers separated by dots, each ranging from 0 to 255. This format allows for about 4.3 billion unique addresses. As the internet grew, we needed more addresses, leading to IP version 6, which looks like a really big number that you see here in the visual, and provides an almost limitless supply of unique addresses. But remember, IP addresses will be impractical for humans. That's where the domain name system DNS comes in. translating human-friendly domain names like throwtrends.com into machine-friendly IP addresses. When you type a website address, first your computer checks if it already knows the IP address. Second, if not, it asks a DNS server for the translation. Third, the DNS server responds with the IP address. Fourth, your computer connects to that IP address to access the website. Domain names are hierarchically reading from the right to left. They go from most general.com, .org, .edu to most specific like the www subdomain. The internet isn't owned or controlled by any single entity. It's a global collaboration of networks connected through a backbone or high-capacity data links. The physical infrastructure includes undersea fiber optics cables connecting continents, terrestrial fiber networks crisscrossing countries, satellite links reaching remote areas, data centers housing servers and routing equipment. When you access a website, here's what typically happens. First, you enter the URL in your browser. Second is your device uses DNS to find the server's IP address. And third, the browser sends a request from the web page to that IP. Fourth, the request travels across multiple networks to reach the server. Fifth, the server processes the request and sends back the web page data. And the sixth, your browser receives and renders the web page. This process involves multiple organizations, internet service providers, ISPs that connects end users, backbone providers that operate long-haul connections, content delivery networks or CDNs that store copies of popular content closer to users, hosting companies that provide server space for websites. This decentralized architecture makes the internet incredibly resilient. But if one connection fails, data can typically find another path to its destination. Increasingly, our devices connect without wires, using radio waves to transmit data through the air. This wireless connectivity comes in several forms. Wi-Fi networks use radio frequencies to create local wireless networks. The Wi-Fi standards like 102.11ac or Wi-Fi 6 define how devices communicate, with newer standards offering better speed, range, and capacity. Cellular networks like 4G and 5G connect mobile devices over much larger areas. These networks use a system of cell towers that hand off connections as you move around. Bluetooth provides short-range wireless connections for peripherals like headphones, speakers, and keyboards. It's designed for low power consumption rather than high data rates. These wireless technologies have enabled the Internet of Things, or IoT, connecting everyday objects like thermostats, light bulbs, and appliances to networks. Wireless networks face unique security challenges since their signals can be intercepted. This is why encryption protocols like WPA3 for Wi-Fi are critical. They scramble the data so that even if someone intercepts it, they can understand it without the decryption key. As our lives become increasingly connected, network security becomes crucial. Several key technologies help protect our networks. Firewalls monitor and control incoming and outgoing network traffic based on predetermined security rules, acting like a barrier between trusted and untrusted networks. Encryption transfers data into code to prevent unauthorized access. When you see HTTPS in your browser with a padlock icon, that indicates encrypted communication. Virtual private networks, or VPNs, create secure tunnels through public networks, protecting your data and providing privacy by masking your IP address. Authentication systems verify that users are who they claim to be, often using multiple factors like passwords, biometrics, or security tokens. Despite these protections, networks face constant threats from malware, phishing attacks, and other cybersecurity challenges, making security an ongoing concern rather than a one-time solution. From local Wi-Fi networks to the global internet infrastructure, interconnected computing systems have fundamentally changed how we live, work, and communicate. Understanding networks helps you make better decisions about your own digital life, from setting up your home Wi-Fi securely to recognizing potential online threats. In our next video, we'll explore our final topic in this series, the path to AI, or artificial intelligence, how simple binary calculations evolved into systems that can recognize images and generate human-like text. So how's connectivity changed your life or work? Let me know in the comments below. And if you like the video, please give me a thumbs up and consider subscribing. This is Ivan, helping you understand the technologies shaping our world. Thanks for watching, and I'll see you in the next.